So again, you start out by solving for your x value, by finding the x value of your vertex. And you have to have this memorized, x equals negative b over 2a. So I would just rewrite it as negative parentheses over 2 times parentheses. Now I would plug in the values of b and a. The b value is 2, the a value is negative 1. So you really have a negative 2 over a negative 2, which is positive 1. So your answer is positive 1. That's your x value of your vertex. Now keep in mind, right there you already have another answer to this homework. It says state the axis of symmetry. What's the axis of symmetry? I'll put a of s. It's going to be x equals what? 1. It's simply the x value of your vertex. We just found the x value of your vertex. So the axis of symmetry, the actual answer is x equals 1. That's the equation. X equals 1. Now, I might as well graph the axis of symmetry. If you go to a graphing calculator and you type in x equals 1, it'll give you a vertical line through the x value of 1. So my axis of symmetry is right here, guys, right through the x value of 1. It's going to provide a reflection. First, technically, I'm supposed to find my vertex, so I got a little ahead of myself. But let's find the vertex. We already have the x. Let's find the y value by plugging in the value of 1 in for x right there and right there. So I rewrote my equation, but instead of the x's, I put parentheses. Let me plug in that value of 1. Okay, so you need to do exponents first. 1 squared is 1, so you really have a negative 1 plus 2 plus 3. So that's really just going to be a final answer of what? 4. That's right. Now, what is that value that we just, what is 4 really?
Y.
It's the y. Y equals 4, and we're talking about the y on the vertex. So our vertex is 1, 4. So let me go to the coordinate 1, 4. That's up here. We already drew the axis of symmetry right through it. We already know that the equation of the axis of symmetry is x equals 1. All we need is more points, ladies and gentlemen. So one option is to do a quick XY table and plug in some values that are on the same side. So you could pick like 2 and 3. You don't want to pick 1 because you already plugged in 1 into x. That's how we got the vertex. But you could pick 2 and 3, or you could pick 0 and negative 1. So 0 and negative 1. But you know what? Instead of doing that, instead of wasting time with math, we know that this a value is negative 1. So if you know that the a value is negative 1, you could use the pattern. The pattern is 1, 1, 2, 4, 3, 9. This is a pattern. These are not coordinates. This is a pattern from the vertex. Now we know that the a value is negative, so it's opening down. So I'm going to go 1 over 1 down, and I'm going to put a dot right there. I'm going to go from the vertex again, 2 over 4 down, because it's 1, 1. We already did that. 2, 4. 2 over 4, 1, 2, 3, 4 down. That'll be the coordinate 3, 0. And the last one is 3 over 9 down. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Way on the edge right there. Now, the beauty of having the axis of symmetry drawn is that you can map it over to the other side. I mean, check that out. That was really easy to graph. You have your perfect parabola right there. So we have our graph. And you know what? There was another thing that was missing on the previous video, on the previous question. It asks us on our instructions for the vertex. We found the vertex. The vertex was 1, 4. It asks us for the axis of symmetry equation. We got that. It asks us for, what else? For us to graph it. It asks us for domain and range. Okay, so the domain, x is what? X is all real numbers, because we know that even though it's going down, it's still going to the left and right forever. So x, it really is all real numbers. Now when you talk about range, how about that y? Y is less than or equal to 4. Perfect. Like if you think about, what's the y value right here? the y value is 0, the y value is 1, y value is 3. So 0, 1, 2, 3, it goes up to 4, the y value 4, then it comes back down, right? So y has to be less than or equal to 4. So we covered all that on the other video, but on the instructions it also says, I believe, to find the Y-intercept, yeah? Find the Y-intercept. So when we want to find the Y-intercept, hopefully we remember this back when we did Y-intercepts of lines. How do we find the Y-intercept? If you don't remember, you set x equal to 0 and solve. Now that becomes a very easy thing to do, because if you go to your equation and set x equal to 0, here's x, put a 0 there. You can do this all in your head. 0 squared is 0, 2 times 0 is 0, nothing plus 3 is 3. So the Y-intercept is 3, right? Now we already knew that because we already graphed it and we could already see that it crosses at 3. Does that make sense? So we've answered so many things here. We found the vertex, we found the domain and range, we found the axis of symmetry, we even said the Y-intercept value is 3, and we're good. So you could always, excellent question, we said that the Y-intercept's always going to be this value, and that's true. Because when you set your x values equal to 0, they all cancel out, it's just going to be this value. And that's only when it's in standard form, guys, when it's in standard form. Okay, y equals ax squared plus bx plus c. When you plug in zeros there, then your Y-intercept will be that value, the c value at the very end. Excellent. Thank you. Now, I hope you guys appreciate the pattern 112439. Because if we didn't know this pattern, you would actually have to plug in 0, work it out, get a 3 right there. You'd have to plug in -1 right there and there, work it out and get a different answer, and then map it over to the other side. So the pattern's a lot faster, but remember, the pattern only works when you have a +1 or a -1 as your a value. Number 2, you want to start out with your vertex. The vertex is a coordinate. How do you find that coordinate? X equals -b over 2 times a. What's the b value?
No, 0.
0. That's right. The a value is -1. The b value is the value with the x. There is no x. There's an x squared, but there's no x. So the b value is 0. So when you have -0 over anything, over 2 times -1 in this case, it's still going to be 0. So your x value of your vertex is 0. Now for the y value of your vertex, it's really easy. You simply plug it in, and that's going to be 0 squared. -0 plus 3 is going to be 3, correct?
Yeah.
So there's your vertex, 0, 3. Let's all graph it. 0 on the x, 3 on the y. Here it is. Is this thing opening up or down?
Down.
It's opening down. How do you know? Because a is negative. Excellent. Now, specifically, a is negative what? A is negative what? It's -1. Yes? Now, because you know that the a value is -1, what pattern could we use? 1, 1, 2, 4, 3, 9. Again, these are not coordinates. It's just the pattern from the vertex. So if I go 1, 1 and put a dot right there, and if I go 2, 4, what do I mean by 2, 4? I'm talking about from the vertex, guys. 1, 2, 1, 2, 3, 4. Put a dot right there. And 3, 9. If you go 1, 2, 3, 1, 2, 3, whoa. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. I'm off the graph, but I'm going to put a dot there anyway. And then you map them over to the other side. Remember, there's an axis of symmetry going right through that vertex. That maximum value, that high point. So reflect them to the other side. This one gets reflected over here. This one's 2 units away, reflected over 2 units away. This one that's off the graph is off the graph down there. Connect your dots, and you have yourself a perfect parabola that's opening down. Super easy. So you have your vertex. Okay, let's answer the other questions. What's the axis of symmetry? Okay, so you're going to say x equals 0. That's right. It's the x value of your vertex. That's your answer for that. How about domain? Domain, and we're going to say x equals all real numbers. How about range? Y is less than or equal to what? 3. Excellent. You guys are on point here. Okay, and what else could we say? What's the Y-intercept? You could even see it already. What's the Y-intercept? 3. And like you mentioned before, you could just look at the C value. That'll be your Y-intercept. I think we got it.